Let's go the other direction now. Whoa, I must erase something. All right. We got our three formulas there. X squared plus y squared equals r squared. X equals r cosine and y equals r sine. Now, instead of going from x's and y's into polar, let's go from polar to the xy equations. And we're dealing with equations, not points. Now, we have a couple of different tactics, but I'll discuss them as we go. Actually, one is multiply both sides by r, the other one is square both sides, but don't worry about the square both sides. I don't think we're going to do that in this class. So let's start. Let's start with the problem. Let's say r is equal to -7 cosine of theta. Now, you have some homework problems that are set up as far as like r isn't just equal to something. Like I'm looking at one of your homework problems where it's like r cosine equals -7. Well, that's not so bad. But this one I'm requiring you to do some work because I would set it up in a proper manner where it's r is equal to some stuff with thetas in it. And it looks like theta determines the radius. It looks like theta is what matters. Like it's like your x now, and the r is like your y. All right. Well, the only things we can mess with is x is equal to r cosine and y is equal to r sine, and I don't see any r squared. So again, when did we solve for variables down in denominators? We don't. So if you ever have a fraction to start off with, multiply, right, goes away, and now we're left with r times cosine of theta is equal to -7. Wait a second, I've seen r cosine of theta. Oh, that's x. It's equal to -7. Come on, that's not so bad. That's going to be a game. That's going to be a tactic. You see the stuff with polar? If you have a denominator, first thing you do, multiply both sides by it. Get rid of it. You just get rid of it, and then we'll start doing some work through there. All right, next one. R is equal to 6 times cosine of theta plus 10 times sine of theta. Now, let me caution you from something. We've used this one before, and I told you, don't use this. That's true. Don't use this with equations, please. Don't do that. First off, we could do that. Watch what happens. All right, now convert these. There's no r's. You can't convert cosine of theta into anything. You can't call it x over r because you still have an r in there. Here's going to be our game. I already kind of said it. You got a couple of choices. Well, let's just stick with one choice. When you're stuck, multiply both sides by r. Multiply both sides by r and see what happens. So we bring the r over here. Because r squareds are dope. Take your r and multiply here, but put it right there. So you get 6 times r cosine of theta. Take that and put it right after the 10. And when we say 10, r sine of theta. Now we can do our conversions. And we don't end up with any weird square roots. Shoot, what if your teacher asked you to graph one of these things? Do you know how to graph? With x's and y's and stuff? I hope so. All right, well, let's change our r squared. That's equal to x squared plus y squared. Shut up, dog. Not you, not you. My dog is growling. R cosine is x plus 10. R sine is y. Oh my goodness. Oh my goodness. That's a circle. That's a circle. Do you recognize it? Do you know these things? Did you know x minus h all squared plus y minus k all squared is equal to r squared is a circle centered? A circle centered at h comma k with r as its radius. Could you tell me where the center of the circle is? Do you remember back to pre-calculus? Do you remember back to trig? Do you remember back to algebra? Where we did things like this? Probably not a lot, but we did. So I'm going to do this. I'm going to this little off topic, but not. It's on the topic. This is just stuff that we should have dialed in. So I'm going to subtract over the 6x. We're going to get everything over to one side. So I'm actually going to write in two different colors. So x squared minus x squared. I'm going to leave a gap. And then let's subtract over our 10y. I'm going to leave a gap and write plus y squared minus 10y. And we're going to set this thing equal to 0. We want to create some sort of perfect square. And we want to create some sort of perfect square. Perfect squares. I wonder if we have any tactics for squares. Like, sometimes we have to complete some, like completing the square. So we're going to do this in two separate ways. We're going to look at the blue. Do not look at the purple. If this was in the quadratic formula, would this not be b? The game for completing the square is take b, cut it in half, and square it. All right, we've done this already in the class. We did it at the beginning. So you get -3. I'd make note of that. And then we're going to square up -3, and that's going to become 9. So we're going to add a 9 on both sides, because this is x minus 3 all squared. See that -3? That wasn't a coincidence. Okay, let's do it again on this one, on y's, and what's in purple. So we find our b. That's -10. We cut it in half. That's -5. And now we square it. But make note of that, -5. That's 25. So we're going to add 25 to both sides of the equation. Cool. So this becomes y what? Minus 5 all squared is equal to 9 plus 25. That's 34. Thus, we have a circle with a center of 3, 5 and radius of the square root of 34. This is what I have my trig students do, where I would actually make them not just convert it, but then graph it. That's the game from trig. All right. We talked about that. We talked about completing the square, how a circle works. You're going to see a lot of stuff in Calc 3 that is not functions. All right, so let's do this one. Let's see if we can't convert another one into x's and y's. So let's take this line that's here. Can you see that it's a line? See that the form is kind of similar to what we had in the last video? Step 1. You ever have a fraction? First step. It's already telling you what to do. Just multiply by that denominator. Right? Because that one will cancel, just leaving it equal to 1. Then we got to bring it over there. So we have r times. And then we put it in. 2 cosines of theta plus 5 sines of theta. Take your r's and distribute them in and put them where they go, because we need them. Oh, there we are. And then we have 2r cosine of theta plus 5r sine of theta is equal to 1. Oh, what's r cosine again? R cosine, x. What's r sine? Y is equal to 1. Well, what if I had to graph that line? Could you graph a line? Would you put it into y equals mx plus b? Because I would just do this. This is the perfect form to graph. This form right here. So what if we just went, let's just ignore that x and say x equals 0. You know x equals 0 is the y-axis. Do you know that? So when x equals 0, this is called the cover-up method. When x equals 0, that just went away, and we'd have y is equal to 1/5. Okay, now let's do the opposite. This is the best form. This is the best form for graphing lines. Now let's ignore that. Right at y equals 0. You know, y equals 0, the x-axis. And now solve. X is equal to a half. Oh, okay, cool. We'll put a half right there. Did you know you only need 2 points to graph a line? Usually a third just to make sure, but bruh, there's a line. Went from this wonky looking thing to, what the hell? Am I back in algebra again? But it doesn't look like a line, and it takes a while for your eyes to get used to which ones are which. And let's do my favorite. Let's do my favorite problem, and we'll be done with this one. Keep it under 15 minutes. r is equal to 3 times sine of theta. We have issues. We can't convert sine into anything, and we sure as heck don't want to use a square root. What could we do to where, wouldn't it be so cool? Well, I don't know about cool. Wouldn't it be so much simpler if that was an r squared? And wouldn't it be cool if there was, again, probably not cool, but wouldn't it be simpler if there was an r there? When in doubt, just multiply by r on both sides. This is probably my favorite problem that I give to trig students. We get this r squared is equal to 3 times r sine of theta. Once again, we get another circle. This is a circle. So we can change our r squared to x squared plus y squared. We can change our r sine of theta to 3y. And we've now converted it into x's and y's. But could we graph it? Can you? It's the same game. It's the same game, and hopefully I can just teach you a little trick through this. So once again, we're going to kick everything over to one side. We're going to move that 3y over and set it equal to 0. Well, what we want is we want to complete the square here. We want to add something to both sides. Okay, cool. So what's our b? Isn't that -3? So I'm just going to jump aside and say -3. And our game is cut it in half and square. Cut it in half? Oh, shoot. -3 over 2. And then square it. And that's positive 9 over 4. All right, so put it at 9 over 4 and a 9 over 4. Now we have x squared plus y something squared is equal to 9 over 4. Cool. Real quick, just factor that up for me. Y squared minus 3y plus 9 over 4. You give me that without telling me what's going on, I'm not going to recognize that. But there's something beautiful about completing the square. Half of b is always what gets added in there. It's x squared plus y squared. X squared plus y minus 3 halves, all squared. And it keeps the sign too. It's really convenient. So it looks like we have a circle centered at well, the x value is 0, right? Notice there's not subtracting anything else. So 0, comma, and then we use the opposite of that sign, positive 3 halves, with a radius of the square root of 9 over 4. You know the square root of 9? 3. You know the square root of 4? 2. The radius in the circle? Wait a second. Hold on. Let me plot that. Call that 3 halves. And if the radius is 3 halves, that means it just kisses right off on the x-axis. And at this point is 3. Let's look back at this problem. Squared plus y squared is equal to 3y. Okay. Y, right? That's y, huh? Notice we're on the y-axis here. You ever get this form? I'm curious. What's the diameter? How far is it? What's the diameter? Is it 3? Wait. Hold on. Let me just do another one and show you how quickly you can get through something like this. I give you r is equal to -2 cosine of theta. Let me graph this thing up for you real quick. There we go. It's a circle that touches the origin right there, and it has a diameter of -2. Does cosine go with x or y? Is that negative? So instead of multiplying both sides by this and going through and going x squared plus y squared equals -2x, and then we kick this thing over and we get the 2x, we make a space and we set it equal to 0, and then we're like, well, what's half of 2? 1. That's 1 squared. That's 1. So we add 1 to both sides, and then we end up with x plus 1 all squared plus y squared is equal to 1, where we have a circle centered at -1 comma 0 with a radius of 1. Dude, that's -1. Oh my goodness. So if we were to recognize that pattern, could you recognize this pattern? R equals -3 sine of theta. Actually, I don't want to use 3. -5. Could you graph that just right off the bat? Could you see what it is? I don't know. Take it or leave it. Just wanted to do it. Let's keep it under 15 minutes. So I'll shut up now. We'll come back. I think we got a little bit of graphing and polar equations. And then we'll get on to calculus.